sellers are prepared to provide at $2 is a total of 10 lattes, right? And carrying on for each of the prices that are specified here, we get a complete schedule. And then we can go to the graph and do the same analysis to get the summation with regard to both of the latte sellers in this hypothetical market. Okay? Now, as in the case of demand, there are certain shifters. The shifters are now going to be different. Because as I indicated, what drives a seller's behavior depends on that seller's self-interest. What's the seller's self-interest? The self-interest turns on how much money are they going to make by selling different amounts of a good or service. In the case of Starbucks, it's how many lattes they can sell. But what really matters to them is not just the quantity they can sell, but what profits are they going to generate from that activity. So the other determinants are the factors that drive that supply schedule and cause it to shift instead of just moving along the supply curve. And once again, if we're just moving along the supply curve, it must be as a result of changing either quantity or price in the two-dimensional graph. All right, what are those factors that shift? Clearly, input prices. What are your cost of goods sold? If you're a seller, you have to go out and combine various inputs. You have to employ labor. You have to buy some raw materials. What are the raw materials in lattes? Pardon? What else? No, okay, so there are two major ingredients right away. Those are raw materials. And if the price of milk goes up or the price of coffee goes up, it is going to increase the cost of producing lattes, right? And you would expect that to have what kind of effect on the supply of lattes? A negative effect. You'd expect, then, the supply to shift to the left rather than the right. Okay, so a fall in input prices makes the production of a particular good more profitable at each output price, and thus the supply should be a larger quantity at each price. And to reflect that, the supply curve has to shift to the right. And here, looking at input prices, using the example we just talked about, suppose the price of milk falls, and each price the quantity of lattes supplied will increase. And here, the presumption is it's by 5 units at each price, and thus we get a shift to the right in the supply schedule, resulting from that change in input prices in contrast to the output price of lattes. Okay, technology is another major shift variable. We talked about that in our first lecture when we looked at productivity. And we said, gee whiz, what drives economic well-being in various countries or societies depends on their inherent productivity. How much value, how much output is generated by labor, employed labor in a particular economy. And here, if we have a change in technology that makes the production process more efficient, there's some major discovery that allows improved processes that require less raw materials, for example, then there is going to be a shift in the supply schedule. And the obvious result, clearly, new technology that comes along that would shift the supply schedule to the left. Would that ever happen? Pardon? Can you imagine technology changes ever shifting the supply schedule to the left rather than the right? Yes?
Well, there's a historical case back with the Dark Ages after the post-Holy Roman Empire, where, for example, they couldn't build aqueducts like they did in the Roman times. They didn't know exactly how to make bricks and clay and concrete the same way the Romans did. So that's a loss of technology.
A loss of expertise, a negative learning process that goes on. It is possible, but it's not very likely, is it? Because why in the world would the sellers adopt a technology that has a negative influence on their well-being? So even if there's some change in technology out there, but it's less efficient than the existing technology, why in the world would they adopt it? Yes?
Would they have to evolve if the market?
Would they have to what?
Would they have to evolve if the market called for it?
If the market called for it, but now the only way the market would call for it if there was an increase in demand because of that for a particular inferior technology, yes, that's possible. But recall that we're focusing now just on the supply side. You've taken us to the full market and saying, suppose there's some demand change that takes place that gives you a preference for an inferior technology. Yes, that's possible. Okay. All right, number of sellers. It causes a shift in the curve to the right. Expectations, as in the case of demand. But now the expectations can't exist with regard to any of the potential variables. And for expectations on the supply side to really make sense, the good or service at the end of the day must be storable. Okay? Because if it's perishable, it turns out that regardless of what your expectations are, you've got to move the product, right? Otherwise, its value is going to go to zero. So an example here is suppose in the Middle East, which we've seen over the course of the last couple of years again and again, lead to expectations of higher oil prices. Now, how's that going to influence sellers in U.S. markets for oil? If you look at an alternative supply of oil in Texas, for example, those owners may decide they're better off by not offering oil to the market today, instead waiting to next month or the following month or next quarter because they expect the prices to rise globally, and thus they will be able to capture more profits by holding their available supply off the marketplace. And as I indicated, that would result in a shift, but also note that this effect of expectations presumes that the goods are not perishable, because expectations are not going to have much of an effect on a good that's perishable, in which next period's price will be zero. Okay? All right. Now, to summarize, as we did in the demand case, this is a simple table just looking at what we have discovered with regard to the major forces. Price, own price. When I say own price, by the way, does that all make sense to you when I say own price? Because obviously we're looking at complements and substitutes. We're looking at prices of other goods, right? So when I say own price, I'm talking about the good that we're analyzing with regard to supply and demand. And I'm drawing the distinction between that price and other prices that are out there that exist for goods that are substitutes or complements. Okay? Input prices. Input price shift the supply curve. It depends on which direction those input prices move. I have to know that before I can determine how the supply curve shifts, whether it shifts to the right or to the left. Technology, same story, although here we would expect it to shift the supply curve to the right generally, certainly. Otherwise, why would the sellers adopt that new technology? The number of sellers also shifts the supply curve. Expectations can as well if it's a storable good. All right. Now, let's look at the two together. Okay. Now, what I have in this simple graph is two equations and two unknowns, right? Back to elementary algebra. I've got a demand curve, which is labeled here D. I've got a supply curve, which is labeled S. If I want to determine, at least algebraically, what is the price and quantity that sets the supply schedule and demand schedule equal, and I'm going to end up with the intersection point between those two curves, and that's going to be, given this graph, that's going to be at a price of $3 and a quantity of 15, right? Okay. But what does that intersection point mean? That intersection point is an equilibrium. At that point, and that point alone, are both the buyers of the product and the sellers of the product totally satisfied. They've got no incentive to move away from that intersection point or that equilibrium. And that is the point at which the quantity supplied equals the quantity demanded. When you get to that price of 3, all the demanders and sellers, all the buyers and sellers in that market walk away from the market satisfied. Right? So our equilibrium has indicated a price of 3 and a quantity moving through the market of 15 units. And all I've done here is outline the schedule for both the quantity demand and the quantity supply curves, and proceeded with a simple algebraic determination of the price that equates quantity supplied and quantity demanded. Now, in real-world markets, are we always going to be at that equilibrium price? Are we?
No.
Why not?
Markets are perfect.
Markets. I thought we said this is a perfectly competitive market. Well, it's a perfectly competitive market, but still, you're quite right. It takes time to find that equilibrium point, particularly in a disorganized. I don't speak disorganized. I should be careful. If I'm running an auction market, we'll find it very quickly. If I'm running a organized market for values of stocks, we'll find it very quickly. Likewise, for any organized commodity market in which there is a schedule of willing buyers and sellers at certain prices. Yes? I'm sorry? By organized, I mean that there is a specific location where all the buyers and sellers must come together. And at that specific location, there is a bid and ask process that goes on until they reach an equilibrium point, and no exchange takes place until that point. Certainly, it happens all the time. The example in your textbook about the market for ice cream in the city of Berkeley. That's not an organized market as I just described it. So now the question is, will that disorganized market still gravitate toward an equilibrium price along the lines of what's shown in this graph? And the argument is that if there are many buyers and sellers out there and they're all price takers, yes. Okay? All right. The equilibrium quantity is determined in the same fashion. And now looking at what happens in the real world, sometimes you get out of equilibrium. Suppose that the quantity supplied, willing sellers are prepared to offer to the marketplace is much greater than the quantity demanded. You're going to have a surplus. You're going to have more in the way of product that's offered to the market, but there isn't going to be sufficient demand on the part of consumers or buyers to pay the price for that particular quantity. Example, suppose the price was at $5. At that particular price, there are a whole bunch of sellers in the marketplace that want to offer a very large quantity relative to what the buyers want to purchase at that price. So, for example, at a price of $5, if we go to the demand curve and then come down to the horizontal axis, we'll see that demanders only want 9 lattes. Right? But the sellers, they want to sell 25 lattes at that price. So what's going to happen? Somebody's going to have to adjust, right? One of either the sellers or buyers are going to have to adjust, and if the sellers want to move more product, they're going to have to lower their price. Okay, so the adjustment process that goes on is that you have the surplus sitting here, and at the price of 5, you've got a surplus of 16, and you're going to go through now a adjustment process where sellers will engage in increasing the quantity that they're selling by cutting their price. And that process will continue until you reach mutual satisfaction. That is to say, both the buyers and sellers have now gone through the adjustment price, and you've gravitated toward the price of $3 in which there is no surplus. Okay? And if I observe a market at a particular point in time, it may not be an equilibrium, but certainly the tendency is going to be to move in the direction of the equilibrium. Now, in addition to surpluses, we can also have the opposite situation, namely where the quantity demanded is much greater than the quantity supplied, and now we've got a shortage, and we'll use as an example a price of $1. Now we see that the buyers want to buy much more in the way of quantity than the sellers want to offer to the marketplace. Right? So once again, we have to go through an adjustment process. At this price of 21, the buyers want to buy 21 lattes, but the sellers only want to sell 5. That results in a shortage of 16 lattes, and that will put in motion an adjustment process where the sellers will see it's in their interest to raise the price in the marketplace, and when they do so, they will see that they can actually increase the quantity that they can sell, and that process will continue until the shortage vanishes, and it will only take place at the equilibrium. Right? All right, so that is the fundamentals of what happens in a perfectly competitive market with regard to temporary disequilibriums and then what the forces are that drive you toward the equilibrium. Now, given everything that we covered thus far, how do we want to use this? We want to use these basic concepts and the market demand and supply and equilibrium conditions to look at various shocks to the market and be in a position to analyze what the results are of those shocks to the market. And I think your book calls them events. There's some event, some change that takes place. Now, you're asked to analyze what are the consequences of that change. Now, to determine those consequences or the effects of any change, there are 3 critical steps. And practice makes perfect. So do your best to repeat these steps over and over again until it becomes second nature, because you will see them on the midterm and the final exam again and again embedded in the various questions that are posed to you. First, determine whether the event that you're analyzing, whether it shifts the supply curve, the demand curve, or both. And you're not going to be able to figure this out unless you're thinking clearly and logically. Okay? Secondly, decide in which direction the curve shifts. And third, given you've got 1 and 2 correct, and if you haven't, don't go to the third step. you're going to get the wrong answer. The third step then is to use the supply and demand diagram to see how the shift changes the equilibrium price and quantity. All right, those are the three basic steps in terms of any analysis associated with a change in fundamental forces and how it influences the allocation of scarce resources, how it influences the market equilibrium price or the market equilibrium quantity. Let's take a concrete example. Hybrid cars. We've seen this happen a number of times over the course of the last 5 years in particular. And it's happened in earlier history as well. Although in earlier history it wouldn't matter because hybrid cars weren't available, right? So the demand for hybrid cars, if you look at the last decade, is a new emerging market that is growing. And what I want to look at is an analysis about what happens with regard to the quantity of hybrid cars versus the price of hybrid cars. Okay? This is the demand schedule. This is the supply schedule. This is the equilibrium quantity and equilibrium price, Q1, and price, or P1. Okay? Now what happens if there's a shift in demand? And the shift in demand could result from an increase in the price of gas, right? Is that correct? Okay. And in which direction would it shift? Who said the left? You were wrong. Okay. All right. To the right. Okay. Because its substitutable product is an automobile. It's a non-hybrid that uses more gas. Hence, if anything, it should shift demand in the direction of hybrid cars. Right? Okay. The supply curve doesn't move, right? The price of gas doesn't influence the production cost, the input prices. And if so, you might be able to conjure up some example where the price of gas has some minor effect on the cost of producing hybrid cars, but it's de minimis at best. Right? So it doesn't really affect the supply schedule, it only affects the demand schedule. So going through our three-step analysis, we would discover that demand shifts and that it, as already indicated, shifts to the right, making hybrids more attractive relative to other cars. Right? And that clearly causes an increase in both the quantity, the equilibrium quantity, and the equilibrium price for hybrid cars. So the new equilibrium price is P2, the new equilibrium quantity is Q2, relative to the initial equilibrium. So in the third step, recall or reflect on the following. The third step, you're always comparing the new equilibrium to the initial equilibrium before the event. Right? And that's what we're doing here. So qualitatively, I know in the new equilibrium, the price is going to be higher and the quantity moving through the market is going to be higher. Okay? And at least with regard, even though I've got a shift in the supply schedule, the demand schedule, in the supply schedule, I'm just moving along the schedule, right? Because it hasn't changed. I'm moving along that, and as a result, it makes our analysis much more straightforward than if the supply schedule was shifting too. Right? Okay. Now, this is a summary slide that goes to language and keeping in mind what we're really talking about. And your book is very deliberate in this respect, talking about a change in supply as a shift in the curve, and that occurs when some external force moves, in effect, the incentives for sellers. A change in the quantity supplied is a movement along a fixed supply curve, and that occurs when prices of the own good change. Same story with regard to demand. A change in demand is a shift in the demand curve. It occurs when when I say non-price, it's non-own price, given what I've defined as the distinction between types of prices. Non-own price, determinant of the demand changes. And the change in the quantity demanded is a movement along a fixed curve. And I'm told that repetition helps. Now, some of you are bored to death because I've said this now 4 or 5 times, and I'm doing so for emphasis because it's important. Because if you don't keep that constantly in mind in terms of your analysis of various problems and or examples that you're faced with, you're going to make mistakes. All right. Let's look at a separate example in which there's a shift in supply, and let's look at new technology that reduces the cost of producing hybrid cars. There's a hybrid car out there, the Tesla. Are you familiar with that? Tesla, there's another car that's been introduced very recently that's also a battery-driven car. It's called the Fisker. And the Fisker is using a new, at least they're alleging to use a new and improved technology versus one of their major competitors, the Tesla. We'll see whether, in fact, that turns out to be true. But nevertheless, if there's some new technology that comes along and it has a positive effect on the cost of production, and a positive effect on the cost of production would be an effect that lowers the cost of production, right? Okay. The demand curve doesn't shift. That new technology, production technology, doesn't influence the behavior of buyers. It influences the behavior of sellers. So this is a technology that lowers those costs, so we have a shift in the supply curve to the right. And now, once again, we go to step number 3 and ask ourselves, what is the consequence of this event? This event being improved technology that lowers the cost of production of hybrid cars. It causes the supply schedule to shift to the right, and the price to fall, and the quantity produced to increase. Right? And once again, it's unambiguous.